Earth Science, groundwater. Have you ever been to a beach, either an ocean beach or a beach at a freshwater lake, or even a beach on the banks of a river? Anyway, at this beach, have you ever dug a hole to discover that as you dig deeper, the hole fills with water? If you've done this, then you've touched the water table. When it rains, water can either run off the surface into lakes and or streams, or into the streets and into gutters, or it can also soak into the ground, where it can become groundwater. The earth below our feet is made of rock and rock material. You've heard the expression solid ground? Well, the ground is solid, but it also has lots of open pore spaces between the rock and sediment grains. As water permeates the ground surface, it fills the open pore spaces. And when these spaces are completely filled, this region is called the saturated zone. The water in this zone is called groundwater. Above the saturated zone is the unsaturated zone, where soil moisture resides. In the unsaturated zone, pore spaces contain water and a significant amount of air. The boundary between the saturated and unsaturated zones is called the water table. So when we dig our hole at the beach and it completely fills with water, we know we're intersecting the saturated zone. Sometimes you need to dig really deep, but sometimes the water table is very close to the surface. It just depends. For one thing, it depends on the amount of water the ground can hold, and this depends on the porosity of the soil or rock. Porosity is the volume of open pore space in sediment and/or rock compared to the total volume of the solid material plus all the open pore spaces. The size and shape of the sediment particles and the packing of the particles affect the porosity. For example, when the ground is made up of rounded particles of similar size, the porosity is high. It can hold a lot of water. But if the ground mass is made up of different sized rock particles of various shapes, the smaller particles can fill the open pore spaces between the larger particles, leaving less room for water, so porosity is low. For water to move underground, it has to be able to flow through or permeate the open pore spaces. And not all pore spaces are created equally. If pore spaces are extremely small and are poorly connected, groundwater may barely move. Examples of this are clay or shale. These types of sediment and rock have very small sediment grains that are finely layered, making it difficult for water to move. The term hydraulic conductivity is used to describe the degree to which geologic material can transmit water. Hydro for water and conductivity for to transmit. So the hydraulic conductivity for these finely layered type rocks is almost zero. In contrast, rock with sand and gravel-sized sediments have large, open, well-connected pore spaces. So water moves freely. These rocks are highly porous and highly permeable. They have a high hydraulic conductivity. So groundwater is stored and flows underground. We call these great reservoirs of groundwater aquifers. They are a great resource and an important part of the hydrologic cycle. Question: we know that rainwater permeates the ground surface and eventually becomes groundwater. Can other fluids permeate the ground? Can only fluids permeate the ground? Onward.